Hello guys, welcome back to YouTube channel. Today we'll be discussing the first 4 problems from the division 4 of the contest Codechef Starters 206. So without any further ado, let's begin.
So let's start with the first problem of the day. The problem title is remaining money. Let's quickly read the problem statement. So chef had n rupees with him. He decided to buy A ice creams for his friends, each at a cost of B rupees. He was able to pay the entire amount. Find how many rupees chef still has left with him at the end. In the input format, we just given three integers n, a, and b. So let me quickly explain you the problem statement. So initially, chef has n rupees with him, and what he does with this is he buys A ice creams, right? And each of that ice cream cost B rupees. And what we simply have to do is calculate the amount that is remaining with chef after he buys A ice creams, which cost B rupees each. I hope the problem statement is clear. It's a pretty simple one. Let's look at the sample input as well to understand it a little better. So in the first test case, we have 100 rupees. The value of n is 100. So chef initially has 100 rupees with him. And what he decides is he decides to buy 5 ice creams, which cost 2 rupees each, right? So 5 ice creams which cost 2 rupees each. So the total amount that he pays is simply 5 into 2, which is 10. So he pays 10 rupees, and if he just simply subtract 10 from the initial money chef had, which was 100, the output that we'll get is 90. Let's look at the second sample case. In this case, the chef initially had 10 rupees with him, and what he does is he decides to buy 5 ice creams again, which cost 2 rupees each. So he has to pay in total 5 into 2, 10, and 10 minus 10, 0. So chef then has 0 rupees left with him at the end. This is the problem statement, and this is exactly what we'll be doing in our code as well. We'll be just calculating this value, the total amount of money chef is paying for the ice cream, and what we'll do is we'll just subtract this from the initial amount of money chef initially had, right? So let's quickly code up this problem as well. Let's quickly look at the input format. We just given three integers, so I'll just take these three integers as input. Right, first let's take n, then let's take A, the amount of ice cream chef will buy, and B, which is the cost of each ice cream. Now total amount which chef will pay here is A into B, and the amount that is left with chef at the end will be simply be n minus amount, and I'll just simply output the amount which is the value in left. Let's quickly run this and see if it will pass the sample cases. There's a small typo here. Let's quickly change that. Yep, it's passing the sample cases. Let's quickly submit this and see as well. Yep, it's passing all the cases. So that was quite a simple problem. Let's quickly move on to the next one. Yeah guys, so for the second problem, the title is expensive buying. Let's quickly read the problem statement. Chef is in a shop with n distinct items. The ith item is sold at a price of Ci. Chef only wants expensive items, so he has decided that he will buy the k most expensive items. Find how much total cost chef had to pay to buy k most expensive items. So let me quickly explain you the problem statement. So in the input, what we are given is an array of n items, right? In the input, we are given an array of n items, and each value in the array represents the cost of the ith item. So in the first case, we have 3 items in our array. The cost of first item is 1, the cost of second item is 100, and the cost of third item is 5, right? And now what chef wants to do is he wants to buy k amount of items, and not just any items. He wants to buy k most expensive items, right? He wants to buy k most expensive items. So this value k is as well given to us in the input, along with the in the first line itself, along with the size of the items. Now if you look at the first example, he wants to buy 3 most expensive items, and the size of the array is 3 as well. So in this first case, he will buy all the items, right? So, and the output that we want to print is simply the total cost of all the items that chef is buying. So in the first case, he wants to buy 3 items. The size of the items is 3 itself, so he will buy all the items, and we'll simply add up all this, and the output is 106. Now let's look at the second case. It's a little interesting one. In this case, we have 3 items here, but chef only wants to buy 1 item and 1 most expensive item. So if you look at that, if you look in this array, 100 is the most expensive item that's present in this list, right? So chef will buy just single item which costs 100, so the output for this is just 100. Let's look at the third case as well. In this case, we have given 4 items, and chef wants to buy 2 most expensive items. What are the 2 most expensive items in this list? It's obviously 9 and 8, right? So chef buys 9s and 8. 9 plus 8 is 17, and that is what we are printing in this output. So I hope the question is clear to everyone. We are just given n items along with k, and what we want to do is simply buy the k most expensive items. And if you look at the constraints as well, that it's pretty low. The number of test cases is just going up until 100, and k and n values also going up until 100 itself. Now how can we solve this problem? So our main goal here is to be able to find out how to get the k most expensive items, right? We have a list, and how to get the k most expensive items from this list. So one simple thing that we can do is we can simply sort this entire array, right? So this is my array initially. Let's look at the first. Let's look at the fourth example: 9, 2, 5, and 8, right? So this was the array given to us in the input, and what I will do is I'll simply sort the array. So after sorting, the array will look something like this: 2, 5, 8, and 9. Now, if I want to get the expensive items, or the k most expensive items from this list, what should I do? I should obviously start iterating from the end, right? Because now my array is sorted, and all the expensive items will be present at the end. So I will just simply start iterating from the end here, and I will iterate the amount of times or the amount of items chef wants to buy. So the last case, chef wants to buy only 2 items, so I will just iterate over the last 2 values, which is 9 and 8, and I will find out their sum and print that as my output. So that's going to be my entire logic for this problem. Simply sort the given array, iterate over the amount of items, iterate over the k amount of items which chef wants to buy from the end. Simply add up all those values and print it in the output. Let's quickly code that problem as well. So in the input, we are first given t, which is the number of test cases. And next we are given in the next line 2 integers, the value of n and k. N is the number of items, and k is the amount of items chef wants to buy. Next, what I'll do is I'll simply initialize an array of size n and take up all those next n items input. Right. Now, what should be my next step? I will simply initialize a sum variable which will store the total cost of items that chef wants to buy. And for finding that cost, first step that I'll do is I'll simply sort the array. I'll simply sort the array. Now, I want to iterate from the end k times, right? Because those many k is the amount of number of items which chef is buying. So I will initialize another index here, which will be n minus 1, and I'll simply add up all these values into my sum variable, and I'll decrement the value of I as well in each iteration. So this loop, what this is doing is simply adding up all the values, all the expensive items from the end one by one. So first it will add the item at n minus 1th index, because of course that will be the maximum priced item in my list, again because my list is sorted, right? Next, the value of I will change to n minus 2. That will be the second most expensive items chef had in his list, and next to n minus 3, and so on, and this will iterate till k times. So in this way we are buying the k most expensive items from the list. Now our only job remaining is to simply print the value of sum. Let's quickly run this and see. There's a small typo here. This would be arrays.sort. Let's try to submit this. Yep, it's passing all the cases. I would say this was as well a very pretty simple problem. Let's quickly move on to the next one. Prime sum is the name of our next problem. Let's read the problem statement. Chef has an integer array a of length n such that a of I is greater than or equals to 1, lesser than or equals to 3. Chef is wondering how many pairs exist in his array which have a prime sum. Formally find the number of pairs ij such that I is greater than or equals to 1, less than j, less than equals to n, and a of I plus j is a prime. Cool. Let me quickly explain the problem statement. So in the input, what we are given is just simply n integers, right? We're given a list of n integers, and each value in that list of integers will only be in a range from 1 to 3. So the values will be either 1, 2, or 3, right? So this is what is given to us in the input, and now what we have to do is we have to find the number of pairs that exist in this list such that the sum of their values is a prime number. The sum of these values is a prime number, and to choose pairs there is this condition provided that if you are choosing any pairs at index I and j, the index of I should be lesser than index of j. So basically this is what we have to find out, the number of pairs in the given list such that their sum is a prime number. Let's quickly look at the sample input to get a better clarity over it. In the first case, we're just having two numbers in the list, 1 and 1, and there's just only one pair that we can form, right? 1 plus 1 is 2, which is a prime number. So the amount of pairs that we can get from this list is just 1. So that's why the output for the first example is 1. Now let's look at the second case. In this we are having three numbers into our list. Now how many pairs can we form with 2? That will give us a prime sum. 2 plus 1, 3. Yes, this will be a prime number. So let me write it down as well. 2, 1, 3. This is the list given. How many pairs can you form with 2? 2 plus 1, the sum is 3. So this is one pair. 2 plus 3, sum is 5. This is another pair. Both of their sum gives us prime numbers, right? Now, can you form any pair with 1 here? We only have, we can only form with 3, which will give us the value 4, which will give us the sum 4, which is not a prime number, right? So we cannot include this into our count answer. We cannot include this into our answer. Now next, we cannot form any pair with 3 because 3 on the right side. So the total amount of pairs that we are getting is just 2, that is 2 plus 1 and 2 plus 3, right? And that's why the output for the second example is 2. I hope the problem statement is pretty clear to everyone. Again, we're just given a list of integers and we just simply have to find out the number of pairs that we can form from the given list such that their sum is a prime number. Now, if you look at the constraints, they are pretty less as well. The length of the array is just going up until 100. So what can we do to figure out the solution for this? Well, what we can do, the exact operation the problem statement is asking from us. So my logic here would be to simply iterate over the entire array, use a for loop, start your for loop from index I equals to 0, that is from 2, and then check how many pairs can you form with 2 as one of them, right? So for that I will use a second for loop as well, right? So I will use the second for loop and the index of the second for loop will be from j equals to I plus 1 now, because if you look at the given condition, j should be greater than I, right? So my first for loop, if it's starting from I equals to 0, my second for loop, j will start from I plus 1. Now, in that way, I can get all the possible pairs. Now, after getting the sum of all the pairs, I simply have to now check if this is a prime number or not, right? So if that is a prime number, I will increment my answer count. If that is not a prime number, I will simply not do anything, right? I don't need to do anything. I will simply move on to the next pair. So if I try to write the code for this, let's try to write the code for this. Let's look at the input format. We're given t number of test cases and then n, which is the size of the array, right? Let me initialize an array with size n, and let's read the input of n values. Cool. So what should be my next step? Now here I will simply initialize a answer variable, or let me rename this to count, since we are counting the number of pairs, right? And so as I've said earlier, I will start my iteration from I equals to 0 till I less than n, I plus plus, right? And for every I will try to find the pairs which I can form with this element at ith position. So in this case, I will start from my second for loop j. Now from I plus 1, j should be again less than n and j plus plus. Now I'll just simply get their sum. This will be a of I plus a of j. Now what we need to do next is we need to check if the given sum is a prime number or not. Now generally we can of course write another function here which will check if a number is prime or not. But if you observe the constraints here, each value is only going up until, each value of the array is only going up until 1, 2 or 3, right? So we don't need to write a separate function to check if the sum is a prime number or not. What could be the maximum possible sum value that we could get from this array? since the values are going only up until 1, 2 and 3, the maximum possible sum value of any pair will be 6, right? So if we choose two elements 3 and 3, their sum will be 6, and the minimum possible value of any pair would be 1 plus 1, which is 2, right? So we don't need to check for all the prime numbers here. Since the minimum possible value is going up until 2 and the maximum possible value is going up until 6, we can just check if the given, we know what are the prime numbers in that range from 2 to 6. It's just 2, 3 and 5, right? So I will just check with those three specific prime numbers if sum is 2 or if sum is 3 or if sum is 5, because I know the sum will not exceed 5 and it will not be lesser than 2 as well. So that's why this condition works here, and if that is the case, I will simply increment my count, and now I will simply output the value of my count. Let's try to run this and see. It's passing the sample cases. Let's quickly submit this as well. Yep, it's passing all the test cases as well. Gladiator fighting is the name of our fourth problem. Let's quickly read the problem statement. There are n gladiators standing in a field. They will fight till only one gladiator is left. The other n-1 gladiators have been defeated. Initially, everyone has a skill factor of 0, but for every fight a gladiator wins, his skill factor increases by 1. There will be exactly n-1 rounds. Each round, two gladiators who have not been defeated yet will come and fight. One of them will win, the other will be defeated. The entertainment level of a fight between the gladiators of skill x and y is x plus y. Note that it is possible for the lower gladiator to win as well. What is the minimum and the maximum possible total sum of entertainment level over all the fights? Interesting problem statement. Let me help you understand it. So in the input, what we are given is a single integer n, which is denoting the number of gladiators we have, right? So we have n gladiators, and initially the skill of every gladiator is 0. Initially the skill of every gladiator is 0. Now what will happen is these gladiators fight with each other. So in one round, one gladiator will fight with another gladiator, right? So now the fight will go something like this. If the gladiator who wins will move on to the next round, and his skill increases by 1, right? So this will continue till all the gladiators fight with themselves and only one gladiator is left remaining. So this is the entire problem statement. Now what we want to do here is we want to find the sum of maximum and minimum entertainment level. Now what is an entertainment level? So let us suppose say we have two gladiators fighting. The gladiator of the skill of one gladiator is x, the skill of another gladiator is y. So the entertainment level for that round is x plus y. The entertainment level for that round is x plus y. Now what we want to output is minimum and maximum possible sum of entertainment level of all the fights, right? So let me help you understand this with an example. So initially in the sample cases we have 4 test cases. So let's take the fourth one to understand it a little better. So for n value 4, let us suppose we have 4 gladiators, which is G1, G2, G3 and G4. Now what we want to do is find the minimum and the maximum possible entertainment levels for this one. So let's first try to find the minimum one. In what cases can we get the minimum entertainment levels here? So initially the skill of every gladiator will be 0. So G1, this skill will be 0, this will be 0, this will be 0, and this will be 0 as well, right? So in the first round, let's say G1 and G2 will fight, G1 and G2 will fight, and G3 and G4 will fight, right? So these two gladiators are fighting themselves. These two gladiators are fighting in the first round. What will be the entertainment level of this round? The skill of gladiator 1 is 0, the skill of gladiator 2 is 0, right? So the entertainment level for this round will be 0 plus 0, which is 0. Same goes for here as well. This will be 0 as well. Now let's say the winner of this round is G1. Now the skill level of G1 will be 1, right? Because every time a gladiator wins, his skill level increases by 1. Now let's say the winner of this round is G3. Now the skill level of G3 changes to 1 now. And now we just have only two gladiators remaining, G1 and G3. Now if they fight themselves, G1 and G3, with their skill 1 and 1, what will be the entertainment level of this round? It will simply be 2, right? It will simply be 2. Now to find the answer, total entertainment level, we simply add up the entertainment values of all the previous rounds. So this round has 0 entertainment value, this round has 0 entertainment value as well. Our third round had 2 entertainment value, right? So the overall sum will still remain 2. And if you observe, this is the answer for the minimum entertainment value for n equals to 4 as well. So for n equals to 4, this is the answer, 2. Now as you can see, the maximum value of entertainment that we can get here is 3. So when would that happen? When can we get total entertainment value as 3? So that could happen. Let's initialize them again. G4. Yep. Now let us suppose instead of G1 and G2 fighting with each other and G3 and G4 fighting with each other, in the first round G1 and G2 fights. So G1 and G2 fights with each other, and let's suppose say the winner is G1 now with his skill level 1. Now let's pair up G1 with G3 now, right? G1 skill level is 1, G3 skill level is 0 itself because he has not fought any rounds till now. And in this case as well, let's suppose say winner is G1, right? His skill level will now be 2. His skill level will now be 2. So and in the next round again we have G1 and the only fighter remaining here is G4. So G1 skill level is 2, G4 skill level is still 0, and in this case let us suppose say again the winner is G1 itself. So in this case, what is the sum of total entertainments value that we are getting? The entertainment value for this round is 0 itself, right? Because 0 plus 0, 0. What is the entertainment value for this round? In this case, this would be 1, right? 1 plus 0 is 1. So in this case, this would be 1. What is the entertainment value for this round? In this case, this would be 2. So 2 plus, now to get the total entertainment value, we'll just do 2 plus 1 plus 0, which will be 3. So in this way, the maximum possible entertainment value that we're getting is 3. whereas the minimum possible entertainment value that we're getting is 2. So I hope the problem statement is clear to everyone. Now let's see how we can efficiently solve this problem. Now for the solution part as well, let's divide this into two separate parts. First part for finding the minimum possible entertainment value, and the next part for finding the maximum possible entertainment value. Right. Now let's look at the second part first. Second part first. How can we find the maximum possible entertainment value? Now, when do you think we could get maximum possible entertainment value for any round? Of course, the skill level of the gladiators participating in that round is higher than the total entertainment round, then total entertainment value from that round will be higher, right? So that is what I will be trying to do for my maximum entertainment value part. What I'll do is I'll just pick one gladiator and I will make him win every time, right? So ideally any one of the gladiators can win, even the one with the lower skill value. We don't have a restriction on only higher skill value gladiator can win a fight. That is not the case here. Any gladiator can win. So what I will do here is, to get the maximum possible entertainment value part, I will pick one gladiator and I will make him win every time, so that his skill constantly increases and the total entertainment value from his rounds as well will be higher, right? Let's take a look at this case itself. In this, I'm picking G1 to win. His skill will now change to 1 for the next round, and I will pair him with G3. Entertainment value for this round will be 1, his skill will be 2. Next, I will pair him with G4. Entertainment value will be 2 and his skill will be now 3. Now that's it. We had 4 gladiators here. So to get the total entertainment value, we'll just do this: 0 plus 1 plus 2, which is 3. This is the maximum possible entertainment value that we can get for this one. Now let us also take a look at, yep. So let's take a look at this. N equals to 5, right? For n equals to 5, what could be the possible values that we would get here? First, I will make G1 and G2 fight. Let's say G1 is the winner here. G1 is the winner. His skill level changes to 1, and the entertainment round value will be in the first round. It will be 0 itself, right? Now their skill levels as well would be 0 initially. Now again, I will follow the same process. I will pick G1 itself and I will make him pair with another gladiator. Now in this case, again G1 will win. His skill level increases to 2. The entertainment value now will be, in this case for this round, will be 1, right? Because 1 plus 0 is now 1. Now let me take G1 again and let me pair with G4 now. In this case, again G1 will win. His entertainment value will now change to 3, and his skill level will change to 3, and the total entertainment value from this round will now be is 2 plus 0, which is 2, right? We have another gladiator left, G5. This will be the last round. Their skill level will be 3 and 0, and in this case again G1 wins, and his entertainment value is not entertainment value, his skill value will go to 4, right? And the entertainment value will go to 3. Now to get the total sum, we'll simply add up all this: 3 plus 2 plus 1 plus 0. This will give us 6. So 6 is the total maximum entertainment value that we can get for n is equals to 5. And if you look at the output, that is what is given here as well, 6. Now how can you get this final value from this given n? So if you observe here, since we are making gladiator one win every time, right? So the maximum possible skill value that he could reach would be n minus 1. Right? If n equals to 5, the maximum possible skill value that he could reach would be n minus 1, 4, and the entertainment levels from each of these rounds, they will have the following value, right? So the first round will have 0, the next round will have 1, the next round will have 2, and the next round will have 3. So this is the way the entertainment value for each of these rounds are increasing. Now, can you give me any formula which will just give me, can you derive any formula from this which will give me this exact value? Yes, we can simply do here n minus 1 into n minus 2 by 2, right? We can simply make use of this formula. Again, how are we getting this formula? Just simply observe this pattern, guys. So 0, 1, 2, and 3, right? So the entertainment value of each of these rounds are increasing in the following way. So if n is 5, the entertainment value of the last round will be 3, which is nothing but n minus 2. If the n is 5, the entertainment value of the last round will be 3, which is nothing but n minus 2. And what I simply want to do now is simply find the sum of all the numbers from 0 till n minus 2. And how can I do that? I can do that by using this formula. I'll repeat the statement again. For any given n equals to 5, using this approach, that is making one gladiator win every time, the last entertainment value that we'll get will be n minus 2. And to get the total entertainment value, we just simply have to add up all these values together, 0 plus 1 2 plus 2 plus 3. So nothing but sum of n natural numbers till n minus 2, right? So we can get that using this formula, n minus 2 into n minus 1 by 2. So this will simply give me the max entertainment value. Now, what about the minimum entertainment value case? When could that happen? Let's take the same case, n equals to 5 itself. G1, G2, G3, G4, and G5. These are my gladiators. Now, this approach would not be suitable for minimum possible entertainment value case, right? The approach where you take one gladiator and make him win every time, in that would not be suitable for the minimum entertainment case. When we could get minimum here? Let's see. If we could now, to get the minimum, I want the skill level of the gladiators participating in each round to be as minimum as possible, right? To be as minimum as possible. So what I will do is I will pair these two gladiators up, these two gladiators up, right? So initially G1 and G2, their skill levels are 0 and 0. Let's say G1 wins here, his skill level changes to 1, and the total entertainment value that we'll get from this is 0 itself, right? Next we have G3 and G4. Let's say G3 wins here, his entertainment value, his skill value changes to 1, and the entertainment value will now change, will be 0 itself, because their skill levels are as well 0. Now what do you think should be our next step? Now if I pair G1 and G3 together, the entertainment value will now for that round would be 2, right? That is why I will not do that. I will not pair G1 and G3 together. What I will do is I will pair G1 and G5 together. Skill level of G1 is 1, skill level of G5 is 0, and let's I will, in this case I will make G5 win, so his skill level changes to 1 and the entertainment value from this round will be 1 itself. Now I only have G5 and G3 remaining. Their skill values are 1 and 1. In this case anyone can win. This is my last round. Let's say G3 wins, his skill value changes to 2, entertainment value for this round will be 2. Now to get the total value, again simply add up all this. So 2 plus 1 is 3. So total entertainment value for this round is, minimum possible entertainment value for this round is 3, and if you observe, that is what the output here is present as well, right? 3. So what could be the pattern here? So again, my only goal intention here is to make players with the lower skill value win every time. Don't make players with higher skill value play each other, right? Always the lower skill value, or gladiator should win. So if you follow that pattern, this would be my first round, this would be my second round, and I will take the winner of these 2 rounds, pair him with G5. I will make G5 win in this case, and then this will be my last round. In the last round, any of the players can win because they both have the same skill level. So if you observe this pattern, the minimum possible entertainment value we can get from this will always be equals to n minus 2, n minus 2 itself, because in the first round we will have 0 skill in the initial round when we are pairing them with each other, right? And as the rounds progress, we will make the lower skill value pair win every time, so the skill difference will always be 1 itself, and the total value that we will get will be equals to n minus 2, will be equals to n minus 2. So this is the pattern that you would have to observe while following this approach. Now you can verify this with any other example as well. Let's check with n equals to 3. We have already seen n equals to 4, n equals to 5. Let's check n equals to 3, G1, G2, G3. Now in this case we'll make G1 and G2 play, right? And let's say the winner is G1, skill level goes to 1, and we'll make G1 and G3 play, and in this case let's say the winner is G3, and his skill level goes to 1. So their initial skill levels were 0, and this value will be 0 itself, and in this case his value was 1, this value was 0, so the value in this case would be 1. So the total value that will come out to be here will be simply be 1 itself. So this is the pattern that we would have to observe here. I'll repeat it again. For minimum possible value, we'll make what we'll do is we'll try to always make the lower level skill player win. In that case, the total answer that we would get is n minus 2. In the maximum possible case, pick any gladiator G1, make him win every time, and the maximum possible value that we will get is n minus 1 into n minus 2 by 2. That was the entire approach. Now if you figure out that part, then the writing code is very easy for this problem. Let's take the input format, t number of test cases, and the next line just contains n. So the minimum possible value will be nothing but n minus 2, and the maximum possible value will be n minus 1 into n minus 2 by 2. And we want to print minimum plus maximum. Let's run and see if this will pass the sample cases. Yep, let's try to submit this as well. Yep, this is passing all the cases.
So that was it for this video. If you have liked the content, please make sure to like, share and subscribe for more such videos. See you in the next one. Bye-bye.